Hi everyone, my name is Sid, and today I'll be showing you how this pendulum might have more in common with waves than you might think. We'll be doing this through providing you with a home experiment that you can hopefully do with materials lying about your house. So let's get started. Alright, so in order to do this experiment you just need three things. The first thing is this pendulum. I made this pendulum by using floss and by tying it around a marble. You can also make pendulums other ways, by using string or by using even a rock instead of a marble. All you need is something that can swing back and forth and is pretty consistent in the way it moves. The next thing you're going to need is some sort of gridded paper. So I used this paper, which was a white piece of paper that I drew grid lines on, and each one of these lines are 2 centimeters long. The point of this is that you should be able to use this in order to measure where the pendulum is so that you can actually make a table of measurements later. I'll talk more about the table later, but as long as your grid is consistent and you can accurately figure out where the pendulum is at any given point, you should be good to go. Last thing you're going to need are some pins. These pins should be able to keep the paper and the pendulum up so that you can keep them in place while you record them. And as long as you have 4 or 5, you should be able to keep it pretty okay. The last thing you're going to need that I forgot to mention is a cell phone. As long as you're able to record the pendulum moving in some way, you should be good to go. Alright, and just to check in, here's what your final setup should look like. You should have 4 pins holding up your grid paper, which would be having the measurements you're going to be taking. And you should have 1 pin above the grid paper with the pendulum centered at the middle. Now I'll be showing on video what you moving your pendulum should look like. I took this video with my own camera, so yours should look like something similar. Alright, so now that we have our data from taking the video, we can use that to construct a graph which we can use to show how a pendulum represents a wave. So, on the left here is the first image from the video. As we can see, I'm holding the pendulum to the right, and this is before the pendulum has started moving. So, how do we use this to get some sort of plot that we can use to show how a pendulum is a wave? Well, we use this table here. So, table is essentially a way of listing certain values that you need to get plotted. The reason it's important here is because we're going to be plotting different combinations of values than the x and y combinations we see here on this graph. So, how do we find our values? Well, let's look at our time column first. So this is before we let go of the pendulum, which means that our time is equal to 0, or the starting point, as the pendulum hasn't started moving yet, so we say that 0 seconds has passed since we let go of it. What's our x? Well, if you look at our graph here, we can see that the pendulum is about at 11, since my finger covered that up here. So our x position is at 11, and our y position is about at 1, since we can see right over here that on the y side of the graph, that the pendulum is approximately at that height. So our y position is 1. Alright, now I've brought in an image of where the pendulum is about 1 second after I let go of it. So that means our time value here is 1. And let's look at our x position. So if we look over here on the graph, our x is about at probably -9, since that's the number that's behind the pendulum here. So we can say that our x position is -9, since that's the value that corresponds with that on the graph. And our y position is at 0, since it's at the very center of the y-axis. So we just put in 0 for a value here. Alright. So, I went in ahead and filled in the rest of the table values since we did the first 2. So now we're going to be using this to plot a graph which looks like a wave. How are we going to be doing that? Well, we're going to be doing that through plotting the time versus the x position, rather than the x position versus the y position like you might be used to. Now, this is what we call the parametric graph, but don't worry about that fancy wording. Just think of it as a graph that's based on time rather than based on position. So we have our table values here. How do we plot it on this graph? Well, if you've noticed, the horizontal axis here represents t, or time, which means that our first column on this diagram here will correspond to the value along the horizontal axis of whatever point we're using. And since our vertical axis is our x position, therefore, that value will correspond with our second column of the plot that we have. So, at time is equal to 0, which means that at the very center of the graph here, our x position is equal to 11, which is about right there, which means that our first point on this graph here is at 0, 11. Because our t here is 0, and our x position here is 11. Okay, what's next? Well, our next point here is time is equal to 1, then x position is equal to -9. So we look to the horizontal axis for time, so we see that we have 1 here. And we look to the vertical axis for x position, which is -9. So we go to 1 here, and then we go down to -9. So our point here now is 1, -9. And we keep on doing that. So a t is equal to 2. We're on the second point here, and our x position is 8. So we find 8 on the vertical side and 2 on the horizontal side. And that's our new point. 2, 8. And we keep on doing that. So it turns out if you plot how the x position changes along with time, you actually get something that looks like a wave, because the x position goes back and forth as time moves on. Also, another cool thing about this wave is that it gets smaller as time goes on. This has to do with the fact that the pendulum keeps on hitting the back of the wall, which causes it to get slowed down by friction. This isn't all too different from what you might think of as a sound wave going out. The further out it goes, the weaker it gets, because as it travels further, it gets more and more spread out and more difficult to hear. So this pendulum actually is something similar in the way that it slowly gets weaker and dies out as things go on. You can also try seeing how the y position changes. Now for my experiment, the y position values weren't that great because my pendulum oscillated very closely to the y-axis, but if your y position values vary more, you can see what sort of wave it produces, kind of like what we did with the x position. Alright, so hopefully this was able to give you a general idea of how we can show that a pendulum is a wave. Alright, thank you so much for taking the time to go through this experiment. The pendulum was one of the things that interested me the most when I started learning physics, and I hope it interested you too when you were doing this experiment. Alright, thank you. I'll see you guys later. Bye-bye.